Okay, so our group is doing continuity. So first, really quick, I will give the definition of continuity. And continuity, a function f is continuous at a if the limit as x approaches a of f of x equals a. So if f is not continuous at a, then a is a point of discontinuity. So basically, for a function to be continuous, it needs to follow the three rules of a continuity checklist. And the first rule is f of a is defined, which means that a is in the domain of f.
Basically, in continuity, we have the checklist. The second checklist specifies that as x goes to a, the limit of x exists. So it's the same thing on the both sides, on the positive and the negative side. So as limit x goes to a, and the positive direction is equal to the limit x goes to a on the negative direction.
So the third checklist in the continuity checklist, or third item, is as a limit of f of x, as x approaches a, it must equal f of a. So, which basically means that the value of f is equal to the limit of f at a.
So basically, a good rule of thumb is whenever you're looking for continuity, you want to, if you can draw your line or your function without picking up your pen or pencil, then it's going to be continuous. If you have to pick it up, then it's going to be discontinuous at that point. So basically, right here we have a graph. We've graphed f of x, and we're going to show some discontinuities, where they fail at each rule on the checklist. So the first one is going to be at 1. It fails the checklist because f of 1 is not defined. For this to be continuous, f of 1 must be defined, and it's not. So it's discontinuous at 1. Here, f of x is discontinuous at 2 because the limit of f of x is not equal to the function value of f of a. So the limit as x approaches 2 is going to be 1. And f of 2 is going to be 3. So these have to be equal to each other for it to be continuous, and it's not, so it's discontinuous. Here is an example where it fails at the second rule on the checklist. The limit of f of 3 does not exist. So basically, a way to check that is to find the limit is you take the limit as x approaches 3 from the left, and it's going to be 2. And then the limit as x approaches 3 from the right is going to be 1. So 2 is not equal to 1, therefore the limit does not exist. Here's another example of discontinuity because, as you can see, there's a vertical asymptote at 5 of f of x, and the limit does not exist at 5. So this is also an example of rule number 2 failing. So whenever you're writing the intervals for continuity, you want to use brackets and parentheses. So the brackets are when you're including that number, and the parentheses is when you don't want to include that. So, for example, the first interval of continuity would be 0 to 1. And there's a bracket around 0 because f of 0 is defined. And there's a parenthesis around 1 because f of 1 is not defined, therefore it runs all the way up. It gets really close to 1, but it never actually hits 1. So it's not continuous all the way to 1. And basically that is continuity. Thanks for watching.